Okay, this is the third video in 1.2 atomic structure. In this video, we'll tackle, next slide, the last box there. The arrangement of electron in atoms and monatomic ions can be described in terms of shells and subshells. I will actually do this box and also what you're meant to do, which is to write electron configuration using subshell notation in 3 videos. So this first one, we'll just talk about what subshells is and why people are using it. All right, so let's talk about, well, mainly main shell to start with. Now, this slide itself was in the previous lecture video, probably the first one actually. That's a diagram that everyone's used to. There's nucleus and there are electrons surrounding it, and a certain number of electrons can fit into each shell. For example, that's a carbon, and carbon has got 2 in the first shell and 4 in the outermost shell. In this case, that's the second shell. Each element have got different number of electrons. Therefore, as you go down the periodic table, you would see element or atom with a lot more electrons. And if one main shell is filled up, I hope you remember, you have to add another shell and electron will start living in there. So that's where we are. Let me just get to the next slide. Okay. All right. Now, so that's where we were, and this is where we want to talk about subshell configuration. And I highly suggest you to have this lecture note next to this video while you're watching, so you can copy it down and add what I'm saying to it. Okay. Hence we do this as well. All right. So electron configuration of atom itself. So what do we know? Well, we've been using main shells and that's it. The way in which electrons are arranged around the nucleus, and that's what it should tell. In a stable atom, that means any element that you see on the periodic table, all the electrons want to be as close as the nucleus as possible. Why? Because it's easier. That's really that. Electrons are lazy bums. They don't want to move up the shell unless they were given large amount of energy, or if they don't have to. This means that electron will generally occupy inner shell first. So as I mentioned with carbon just then, 2 would be inside inner shell and 4 would be in the outermost shell. In terms of hydrogen, as an example again, it only has 1 electron. So it wants to be in the first shell. It doesn't want to be in the second or third shell. Helium has 2 electrons, and they would occupy the space, 2 spaces in the first shell, and that's it. Unless they had a lot more energy, they don't want to go into second or third shells. Lithium, okay, the third element, 2 electrons out of 3 would be in the first shell, and the leftover one, now it doesn't have the choice other than going upstairs, going up to somewhere that requires energy to go up. So the third electron there has to be in the second shell, and that's going to be the only electron. All right, so if you're asked to write an electron configuration, 2, 1 should have been the one that you have been used to doing, and that would have been it. But people thought that there are certain issues around it. Okay, so we'll talk about limitation in a minute. For main shell notation, we have been using 1, 2, 3, 4, and which are okay. So main shell number 1, 2, 3, 4, the first one being the closest shell, and the later numbers will be outer shells. Depending on the textbook, you might see these letters starting from K. So K, L, M, N, that also represents main shell 1, 2, 3, 4. They just mean the same, but it's just different way of writing it. Now, limitation of the electron configuration writing with main shell. They have got certain limitations to it. Things like why certain shells can have more than 8 electrons. If you're only using main shell notation, it doesn't explain that. Secondly, why do shells have particular energy? Again, main shell electron configuration idea doesn't explain it perfectly. And thirdly, why do electrons move in circular orbits rather than elliptical ones? That's again, more to do with quantum mechanics, but it doesn't explain it well. So let's bump it up to year 11, year 12, SACE level of chemistry here. All right, so then people came to this idea of subshells. Within the shells, there are energy levels of similar energy called subshells. It's basically like blocks in the same level. So if you think about main shells as a same level that exists in a hotel, there are certain rooms, and the rooms can be classified as certain category. For example, certain rooms in the same level of hotel could be very cheap. There are rooms for, I don't know, normally paid people, and there are certain luxury, much bigger rooms where people have to pay a lot more, but they still exist in one level. That's the idea. So main level of a hotel being the main shell, and sections that exist within a main shell is considered like blocks. And blocks is actually the word that we'll keep using as well. Subshell, they are represented with lowercase letter of SPDF. SPDF. That's it. Don't ask me why, but SPDF are the ones that's used. They're always lowercase. Don't use capital. The energies of subshells within a shell increase in that order as well. SPDF, S being the subshell with lowest energy, and F being the highest. It's kind of like cheapest rooms and luxury rooms within the same level. Okay. Subshells with lower energy gets filled first. Naturally, electrons don't really want to pay. They're also cheap skates as well. So they want to fill up S once first, P next, D, and if F is available, they might have just no choice but to pay for the F rooms. Okay. Next slide is this table. We'll cover this. It's actually here, but we'll cover this in the next video. All right. Thanks for watching.